The water was 50 meters deep, pitch black, and closing in. Oberleutnant zur See Klaus Hartmann sat in the commander's seat of U-2511, the most advanced submarine ever built, and felt something he had never experienced in 4 years of Atlantic warfare: absolute confidence. No need to surface for air, no need to crawl at 7 knots submerged, no need to fear the destroyers circling above. The Type 21 could outrun them underwater. It could hide in depths they couldn't reach. It could strike and vanish like a ghost. In his hands, finally, was the weapon that could turn the tide. There was just one problem. It was May 4th, 1945. In 4 days, Germany would surrender. The miracle submarine had arrived exactly 18 months too late. This is the story of the Type 21 U-boat, the vessel that rewrote the rules of submarine warfare and pioneered technologies still used today. But it's really about the gap between engineering brilliance and industrial reality, between what's possible in a design office and what's achievable in a collapsing nation, and what it reveals about how desperation, hope, and self-deception can combine to create something genuinely revolutionary that still manages to fail completely. To understand what made the Type 21 so extraordinary and why its failure was so inevitable, you first need to understand what German Naval Command believed in 1943. They believed the U-boat war could still be won, not hoped, not wished, believed. Yes, Allied radar and escort carriers had turned the Atlantic into a killing ground. Yes, U-boat losses had become unsustainable. Yes, the happy time was over. But these were seen as tactical problems requiring technical solutions. German engineering had always been superior. German ingenuity had always found answers. The Type 21 would be that answer. It would be faster submerged than most submarines were on the surface. It would stay underwater for weeks. It would reload torpedoes in minutes instead of hours. It would be silent, deadly, unstoppable. This wasn't propaganda. This was the genuine belief of experienced naval architects, submarine commanders, and strategic planners who had studied every aspect of underwater warfare. They weren't delusional. They were solving the problem as they understood it. What they failed to understand was that by 1943, they were no longer fighting a tactical problem. They were fighting industrial mathematics, and mathematics doesn't care about engineering elegance. The man who conceived the Type 21 was Admiral Karl Dönitz, and his logic was flawless, given what he knew. Conventional U-boats had become floating coffins. They surfaced to recharge batteries and were spotted by radar. They dove slowly and were depth-charged. They crawled underwater at 7 knots and couldn't escape hunting destroyers. The solution was obvious: build a submarine that never needed to surface, that dove faster, that could outrun surface ships while submerged. In February 1943, Dönitz commissioned a design study. By June, the blueprints were complete. By September, construction had begun on a vessel unlike anything the world had seen. The Type 21 would displace 1,621 tons submerged, nearly twice the size of a Type 7. It would be powered by a revolutionary triple-shaft diesel and electric system generating 4,000 horsepower underwater. Its streamlined hull, designed purely for underwater speed rather than surface cruising, would push it to 17.2 knots submerged. No submarine in the world could match that. Most destroyers couldn't match that. It would carry 23 torpedoes and reload them in 20 minutes using hydraulic systems. It would be equipped with a snorkel, allowing diesel engines to run at periscope depth, eliminating the need to surface. It would have improved sonar, radar detectors, and rubber coating to absorb enemy sonar pulses. On paper, it was perfect. The engineering was sound, the physics worked. German test facilities confirmed every capability. What the blueprints didn't show was the nation required to build it. This is where the story shifts from engineering triumph to industrial tragedy. Building a Type 21 wasn't like building a Type 7. The older boats were constructed in traditional shipyards using traditional methods. Skilled workers assembled each submarine from keel to conning tower in a single location. It took about a year per boat. Germany in 1943 didn't have a year per boat. It didn't have the shipyards. It didn't have the skilled workers. It didn't have the materials. What it did have was Albert Speer, the armaments minister. And his solution was as ingenious as it was desperate. Prefabrication. The Type 28 would be built in sections at inland factories across Germany, transported by river and rail, and assembled at coastal shipyards. Section 1, bow with torpedo tubes, built in one location. Section 2, control room, built elsewhere. Sections 3 through 9, hull segments, crew quarters, engine rooms, all manufactured separately. Final assembly would take weeks instead of months. It was revolutionary, it was necessary, and it required a level of industrial coordination that Germany, under constant Allied bombing, could no longer achieve. The plan called for 33 factories producing components, feeding 11 assembly yards, delivering 40 submarines per month. By spring 1945, Germany would have hundreds of Type 21 boats, transforming the Atlantic into a German lake once more. Admiral Dönitz believed this timeline. He restructured the entire U-boat command around it. He pulled experienced commanders from the Atlantic to train on the new boats. He planned operations assuming the fleet would be operational by late 1944. He wasn't lying to himself. The numbers, on paper, made sense. Prefabrication worked in theory, but theory assumed that factories wouldn't be bombed, that railways would keep running, that skilled workers would be available, that quality control could be maintained across dozens of disconnected facilities. Theory assumed a functioning industrial nation. Germany in 1943 was no longer that nation. The first problems appeared during section manufacturing. Tolerances that worked fine when a single shipyard built an entire submarine became critical when sections had to mate perfectly after being built hundreds of kilometers apart. Section 1 would arrive at the assembly yard and not align with Section 2. Bolt holes wouldn't match. Pipes wouldn't connect. Electrical conduits were in the wrong positions. Each mismatch required modification, which required skilled workers and time, the two resources Germany didn't have. Then the bombing intensified. A factory in Bremen producing bow sections was hit in October 1943. Production shifted to Hamburg. 2 months later, Hamburg was hit. Production shifted again. Each move meant delays, lost tooling, workers relocated, quality declining. The railway network began to collapse. Sections sat at factories waiting for transport. When transport came, Allied fighters strafed the trains. Sections arrived damaged, more delays, more modifications. The assembly yards became bottlenecks filled with incomplete submarines waiting for missing components. The quality problems were worse. Traditional U-boat construction allowed workers to see the whole boat, to understand how each system related to every other. Prefabrication meant workers in an inland factory were welding hull sections with no understanding of how they fit into a submarine. They had no submarine experience. Many had no welding experience. They were drafted labor, untrained teenagers, prisoners of war, anyone with hands. The work showed it. Welds cracked under pressure testing. Electrical systems short-circuited. Hydraulic lines leaked. Batteries failed. Each problem was small. Collectively, they were catastrophic. The first Type 21, U-2501, was completed in June 1944, 9 months behind schedule. It immediately went into repairs for defects discovered during trials. The second and third boats followed the same pattern, launched with fanfare, then into the dock for months of fixes. By autumn 1944, dozens of Type 21 boats sat at docks, technically completed, practically useless. They leaked. They broke down. Their revolutionary systems failed because they were built by a dying industrial base that could no longer maintain the standards required. But here's what makes this story psychologically complex. The submarines that did work were extraordinary. U-2511, completed in late 1944 and actually properly built, underwent trials in the Baltic. Commander Adalbert Schnee, one of Germany's most experienced aces, took it through every test. Submerged speed, 17.5 knots, even faster than designed. Crash dive, 18 seconds to periscope depth, half the time of a Type 7. Underwater endurance, 11 hours at top speed, 340 hours at 5 knots. The snorkel worked perfectly. The hydraulic torpedo system reloaded all 6 bow tubes in 20 minutes. The sonar absorption coating reduced detection range dramatically. Schnee wrote in his report that the Type 21 made every previous submarine obsolete. It wasn't propaganda. It wasn't exaggeration. It was true. In the hands of a skilled crew with a properly built boat, the Type 21 was everything it was designed to be. The tragedy was that by the time any were ready, there was nowhere to send them and no war left to fight. Think about what this meant for the men in the program. You're a U-boat commander pulled from the Atlantic, where you've been hunted by destroyers, bombed by aircraft, depth-charged until your ears bled. You're told the new boats will change everything. You see the specifications, you run the calculations. It's not fantasy, it's physics. A Type 21 can do things no submarine has ever done. You train for months learning the systems. You watch your boat take shape in the assembly yard. You believe, genuinely believe, that you're about to receive a weapon that will shift the balance back. Then you take it to sea, and the batteries fail, the hydraulics leak, the welds crack. You return to port for repairs. Weeks pass, months pass. Other boats arrive in the same condition. You hear rumors of boats that work, that perform miracles in trials. But yours isn't ready. None of them are ready. The war is ending, and the miracle submarine sits at the dock waiting for spare parts that will never arrive from factories that no longer exist. This is the belief-reality gap at its most cruel. The Type 21 wasn't a myth. It worked. But it worked in an industrial context that had ceased to exist by the time it was ready. It required precision manufacturing from bombed-out factories. It required skilled labor from a workforce that had been drafted or killed. It required materials from supply chains that had collapsed. It required time from a nation that had run out of time. And yet men kept building them because the alternative was admitting defeat. And Germany in 1944 wasn't ready for that admission. By January 1945, 118 Type 21 submarines had been commissioned. Of those, exactly 0 were combat-ready. The defect lists were staggering. U-3008 had electrical fires. U-3009 couldn't dive properly, ballast systems failed. U-3501 through U-3530, an entire series, had faulty pressure hulls and were scrapped without ever leaving port. The few boats that did achieve something close to combat readiness faced a new problem. There was nowhere safe to train. The Baltic, traditional training ground, was being overrun by Soviet forces. The North Sea was an Allied shooting gallery. Commanders had to choose between inadequate training in dangerous waters or thorough training in waters they'd soon lose access to. Most chose rush training. That created its own risks. A Type 21 was far more complex than a Type 7. It had systems that required practice to master. Rush training meant crews who understood the theory but hadn't internalized the practice. And submarine warfare is not theoretical. The final operational missions tell you everything about genius arriving too late. On March 18, 1945, U-2511 under Adalbert Schnee departed for its first war patrol. A properly functioning Type 21, a skilled commander, finally ready for combat. Schnee headed for the North Atlantic. On April 30th, he detected a British cruiser formation. He maneuvered into attack position underwater at speeds that would have been impossible in any other submarine. He achieved a perfect firing solution. His finger rested on the torpedo release. Then the radio message came through. All U-boats cease hostilities. Hitler was dead. The war was ending. Schnee surfaced, radioed his position to the British, and surrendered. In his report, he noted that the attack would have succeeded. The cruiser formation never detected him. The Type 21 had performed flawlessly. He had proven in combat conditions what the design promised. He proved it the day the war ended. The British interrogators who debriefed Schnee read his reports with professional respect and personal relief. They understood immediately what they had escaped. If Germany had fielded 100 Type 20Is in 1943 as planned, the Atlantic War would have been very different. If they had fielded them in 1944, catastrophically different. In 1945, they proved the concept just as the war rendered it irrelevant. Only one other Type 21 saw anything resembling combat. U-3008 under Helmut Mansek departed on April 30th, conducted a brief patrol, detected destroyers, but was ordered to avoid combat and surrendered on May 4th. That was it. 2 combat patrols, 0 attacks. The most advanced submarine fleet ever conceived achieved nothing because it arrived when there was no longer a war to fight. The irony is almost unbearable. German engineers solved the submarine problem. They created a vessel that would define submarine design for the next 30 years. The streamlined hull, the high submerged speed, the snorkel, the sonar absorption, the hydraulic systems, every major post-war submarine borrowed Type 20 innovations. The American Tang class, the Soviet Whiskey class, the British Porpoise class, all were essentially refined Type 20Is. The design was vindicated by every navy that studied it. Germany just couldn't build enough of them when it mattered, because the nation required to build them was collapsing faster than the submarines could be completed. Now we need to slow down and understand the psychological weight of this for the men involved. You're an engineer at Blohm + Voss. You've spent 2 years developing hydraulic torpedo loading systems that work perfectly. You've solved problems no one else has solved. Your design is brilliant. You know it's brilliant because when the boats work, they work exactly as calculated. But you also know that most boats don't work because the welds from Factory 17 keep failing. The electrical components from Factory 23 are substandard, and the hull sections from Factory 31 don't meet tolerances. You can't fix any of that. Those factories are beyond your control, probably bombed, definitely staffed by people who don't have the skills needed. Your perfect design is being destroyed by implementation failures you can't influence. Do you keep refining the design, knowing it won't matter? Do you try to simplify it, compromising excellence for producibility, knowing it's too late anyway? Do you just go through the motions because the alternative is confronting the reality that your brilliance is irrelevant in a collapsing system? Most chose the third option. Keep working. Keep solving problems. Don't think about the larger context because the larger context is unbearable, or you're donuts. You're not stupid. You receive reports daily. You know the production numbers aren't being met. You know the defect rates are catastrophic. You know the war is being lost. But you also know that every strategic analysis says Germany's only chance is technological breakthrough. The Type 21 is that breakthrough. If you admit it's not going to work, you're admitting the war is lost. If you keep pushing, keep demanding, keep believing, maybe enough boats will become operational in time to matter. Maybe the Allies will negotiate. Maybe the Western powers will see the Soviet threat and make peace. These aren't delusions. They're the desperate calculations of a man who understands probability but can't accept certainty. So you keep pushing production. You court-martial commanders who report defects too aggressively. You present optimistic timelines to Hitler because pessimistic timelines mean nothing gets built at all. You believe and you doubt simultaneously, and the cognitive dissonance is the price of command in a losing war. The systematic denial within German Naval Command is documented in meeting transcripts from late 1944. Officers reported that Type 20 armored boats were not meeting specifications. Dönitz's response was to blame the officers for insufficient training. the crews for insufficient effort, the builders for insufficient dedication. He didn't blame the system because blaming the system meant acknowledging that the system was broken beyond repair. In November 1944, a staff officer presented data showing that at current production rates and defect levels, no significant type fluctuant force would be operational before mid-1946. Donitz rejected the analysis, not because the math was wrong, but because accepting it meant accepting defeat. He ordered production accelerated. More boats were rushed through assembly. More boats failed trials. More resources were consumed producing submarines that didn't work. The cycle fed itself. This is how institutions resist uncomfortable truth. They don't reject the facts, they reject the implications of the facts, and in doing so, they make the facts worse. Individual commanders faced impossible choices. Korvettenkapitän Surin commanded a training flotilla preparing crews for Type 21's operations. He received boats that weren't ready. He had crews that weren't fully trained. He had orders to declare them combat ready. His options were: Option A, report honestly that the boats and crews weren't ready, be relieved of command for defeatism, watch someone else send unprepared crews to sea. Option B, declare them ready, send them out knowing they faced higher risks, but at least you maintain control and can try to mitigate the risks through whatever measures possible. Most commanders chose Option B, not because they were cowards or liars, but because honesty in a system that punishes honesty doesn't help anyone. This is the moral weight of expertise in an organization that has stopped listening to experts. You can tell the truth and be removed, accomplishing nothing, or you can work within the system, compromise, and hope your experience helps keep people alive. There are no good options. After Germany surrendered, Allied technical intelligence teams swarmed over the Type 21 boats with the intensity of archaeologists discovering a lost civilization. What they found confirmed everything and explained everything. The design was extraordinary. The engineering was sound. The innovations were genuine, but the construction quality ranged from adequate to disastrous. British naval architect examining U-2518 wrote in his report, "This vessel represents the most advanced submarine design we have encountered. It also represents some of the worst construction quality we have observed. These facts are not contradictory. They are both true, and understanding why they are both true explains Germany's collapse more clearly than any strategic analysis. The Americans were more direct. They raised U-2518 from Kiel Harbor, refurbished it completely, and commissioned it as USS Nemo. They operated it for years. It performed exactly as designed once American yards fixed all the defects. The Soviets captured several Type 21s and reverse-engineered them to create their post-war submarine fleet. The design worked brilliantly in peacetime with functioning industrial support. It failed catastrophically in wartime with collapsing infrastructure. The submarine was fine. The nation building it was dying. Post-war interviews with Type 21 personnel reveal the psychological aftermath of being part of something revolutionary that accomplished nothing. Adalbert Schnee, who proved the Type 21 concept on its only successful patrol, spent the rest of his life explaining to historians what could have been. He never claimed it would have won the war. He was too experienced for fantasy. But he knew it would have changed the war, made it bloodier, longer, more costly. He knew he had commanded the future of submarine warfare and arrived too late to use it. That knowledge carried weight. He had proven something important at the exact moment it ceased to matter. Other commanders were more bitter. They had trained for years on boats that never worked. They had watched resources pour into a program that produced nothing operationally significant. Some blamed the engineers. Some blamed the builders. Most blamed the system, the chaos, the impossible demands placed on an industrial base that was already broken. The engineer's perspective is more complex. Burkhard Weber, who led the hydraulic systems team, gave an interview in 1972. He said something that captures the entire tragedy. "We knew in 1943 that we had designed something years ahead of its time. We also knew, though we didn't admit it openly, that Germany in 1943 didn't have years. So we were building a future submarine in a present that was ending. That's not an engineering problem, that's a philosophical problem." He understood that the Type 21 wasn't a failure of design, it was a failure of context. You can create perfection, but if the world required to produce that perfection doesn't exist, perfection remains theoretical. The gap between design office and reality isn't just technical, it's temporal, industrial, political, and ultimately existential. Germany needed the Type 21 in 1943. Germany could have built it in 1941. Germany commissioned it in 1943 and received it in 1945. The timeline was off by 24 months, and those 24 months contained everything. Let's talk about the technical legacy because it's substantial. Post-war submarine design universally adopted Type 21 innovations. The streamlined teardrop hull became standard. Previous submarines were surface ships that could dive. The Type 21 was an underwater vessel that could surface. That conceptual shift defined modern submarines. High submerged speed became the priority. Surface speed became irrelevant. The snorkel allowed submarines to remain submerged indefinitely. Soviet boats used snorkels designed from captured Type 21 documentation. American fleet submarines were retrofitted with snorkels based on the same designs. Sonar absorption coatings, first used on Type 21 boats, led directly to modern anechoic tiles. Hydraulic torpedo loading systems eliminated the manual labor that previously took hours. Modern submarines load torpedoes in minutes using descendants of Type 21 hydraulics. The Type 21's influence appears in every submarine design from 1946 to present. It's not acknowledged in every case, but it's there in the hull shapes, the propulsion concepts, the operational doctrine. Germany lost the war, but won the submarine design argument permanently. The production attempt also taught lessons, though darker ones. Prefabrication of complex military equipment became standard, but with important modifications. The Americans building Liberty ships used modular construction, but they maintained quality control by keeping assembly centralized and ensuring component factories met strict standards. Post-war industrial planning recognized that distributed manufacturing requires stable infrastructure, skilled labor, and quality control that can't be maintained during wartime collapse. The Type 21 program demonstrated that you can't solve industrial inadequacy with clever design. You can't engineer your way out of systemic failure. The lesson was learned. Modern military procurement plans account for industrial capacity, not just design capability. The Type 21 showed what happens when you don't. There's a deeper philosophical question embedded in this entire story. What do you do when you can see the solution but can't implement it? When you have the knowledge but lack the means? When you're objectively correct but contextually irrelevant? The Type 21 engineers were right. The submarine was better. The design solved the problems. In any objective comparison, the Type 21 exceeded contemporary submarines in every meaningful metric. They were correct. And it didn't matter. Correctness without capability is just frustration. Innovation without implementation is just theory. The engineers learned something that scientists throughout history have learned. Being right is insufficient. You must be right at the right time, with the right resources, in the right context. Remove any of those elements, and brilliance becomes irrelevance. For the submariners, the lesson was more personal. They trained on boats that represented the future and fought in a war that was ending. The gap between what they were capable of doing and what they were able to accomplish was defined entirely by timing and circumstance beyond their control. Combat effectiveness isn't just about skill or equipment. It's about availability, sustainability, and strategic context. A perfect weapon that arrives too late is indistinguishable from a weapon that doesn't work, at least in terms of operational impact. The psychological burden of that realization, being part of something extraordinary that achieved nothing, marked many of them permanently. They had seen the future. The future had arrived too late to save them. The Allied perspective provides an interesting counterpoint. British and American naval intelligence tracked Type 21 development closely. They knew what was coming. They knew it represented a significant threat. Plans were developed for anti-Type 21 operations. More escort carriers, more destroyer escorts, improved sonar, ahead-throwing weapons like Hedgehog, all were prioritized partially in response to Type 21 intelligence. But Allied planners also understood, earlier than German planners, that the Type 21 production timeline was unachievable. They read the bombing damage reports. They knew the German rail network was collapsing. They calculated that Germany couldn't produce enough boats soon enough. They were right. But they didn't stop anti-submarine preparations because intelligence could be wrong. So resources flowed into counters against a threat that never materialized in significant numbers. Was that waste? Not exactly. The preparations validated Allied industrial capacity. The ability to respond to a potential threat before it emerged demonstrated exactly the kind of strategic depth Germany lacked. The Allies could afford to prepare for threats that might not materialize. Germany couldn't afford to build enough of the weapons it actually completed. That asymmetry decided the war more than any individual weapon system. Now, in the final phase of this story, we need to consider what the Type 21 reveals about hope and desperation in strategic planning. The program consumed enormous resources. Steel that could have built tanks went into submarines. Skilled workers who could have maintained existing U-boats were diverted to Type 21 construction. Factories that could have produced spare parts made hull sections instead. The opportunity cost was massive. From a rational standpoint, Germany should have simplified production, focused on proven designs, maximized output of adequate weapons rather than pursuing revolutionary weapons. But that assumes rational decision-making is possible when you're losing. When conventional approaches are clearly failing, desperation drives innovation. The Type 21 wasn't just an engineering program. It was a psychological necessity. It represented hope that technological breakthrough could offset strategic collapse. Without that hope, what do you tell your submariners? That they're going to sea in obsolete boats against an enemy that can detect and kill them with impunity? That there's no plan except keep fighting until you die? The Type 21 allowed the leadership to believe and to tell their men that better equipment was coming. That belief kept the force functioning. Whether the belief was justified is almost irrelevant compared to its psychological necessity. But here's the uncomfortable truth embedded in that analysis. False hope can be worse than no hope. Resources spent on Type 21 construction were resources not spent on maintaining the existing fleet. By late 1944, standard U-boats were going to sea with defects that would have been caught by proper yard time. Crews were inadequately trained because training facilities were repurposed for Type 21 instruction. The focus on the future compromised the present. You can argue that the present was hopeless anyway, that conventional U-boats were doomed regardless, that Germany needed a breakthrough or nothing mattered. That's probably true. But it's also true that the men who died in Type 7 boats with preventable mechanical failures were casualties of a program that promised salvation and delivered nothing operationally. The Type 21 cost lives before it saved any, because it diverted resources from boats that were at least functional. That's the cruel mathematics of innovation during collapse. The resources spent pursuing breakthrough solutions are resources not spent managing current reality, and current reality is where people are dying today, not in the future when the breakthrough arrives. The final boats were scuttled in May 1945. Over 100 Type 20 submarines were deliberately destroyed by their crews to prevent Allied capture. Some were scuttled in harbor, some were driven into deep water and sunk. A few were incomplete enough to simply be abandoned. The crews sabotaged the sophisticated systems they had spent months learning. They destroyed the technological future of submarine warfare because keeping it from the enemy was the last mission available. Several commanders wrote about the emotional experience of scuttling their boats. They had never taken them into combat. They had never fired a torpedo in anger. They were sinking weapons that represented years of work, months of training, and the hope that maybe, somehow, they could turn the war around. That hope died in the Baltic alongside the submarines. Some men wept. Some were relieved the decision was made for them. Most just felt numb. You spend years preparing for a mission that never comes, and then you destroy the means to accomplish it. There's no precedent for that particular flavor of futility. Post-war analysis, conducted once the emotion receded and the archives opened, reached consensus. The Type 20 was a superb submarine design that Germany couldn't build in sufficient quality or quantity when it needed them. If commissioned in 1942, it could have extended the U-boat war significantly, increased Allied casualties, possibly delayed the invasion of France. If produced in adequate numbers by mid-1943, it could have created serious strategic problems for the Allies. Arriving in 1945 in small numbers with significant defects, it proved the concept but accomplished nothing operationally. The timing was everything. The design was validated by its universal adoption post-war. The program was invalidated by its complete operational failure during the war. Both things are true simultaneously. That's what makes it historically significant and personally tragic. For the men who built, commanded, and crewed these submarines, the aftermath was complicated. Some, like Adalbert Schnee, became respected figures in post-war navies, their experience with advanced submarines making them valuable in the Cold War. Others disappeared into civilian life, their expertise obsolete, their experiences classified. The engineers mostly continued in naval architecture, designing commercial ships, and occasionally consulting on military projects. Their Type 20 work was studied, praised, and built upon, but always with the understanding that it had accomplished nothing when it mattered most. That's a strange legacy, being vindicated by history while knowing you failed in your moment, being proven right by everyone who copied your design while remembering that your version never worked properly because the nation building it was dying around you. There's a final irony worth noting. The Cold War submarine race, the American and Soviet programs that defined underwater warfare for 50 years, were both based substantially on Type 21 innovations. The German submarine that arrived too late to affect World War II shaped the next war before it began. The technology that failed to save Germany became foundational for both sides of the next global confrontation. The engineers who couldn't produce enough working boats in 1944 and 1945 created designs that influenced thousands of submarines built between 1950 and 2000. Their failure in execution became a success in conception. That's cold comfort for the men who scuttled their boats in May 1945, but it's historically significant. The Type 20 lost its war, but won its argument. Progress doesn't care about timing. Good ideas propagate regardless of whether their first implementation succeeds. What's the universal truth here? What does the Type 20 story tell us about innovation, institutions, and human nature? Several things, all uncomfortable. First, being correct is necessary but insufficient. You can solve the problem perfectly and still fail if the context doesn't support implementation. Engineering exists in a matrix of resources, infrastructure, skill, and time. Optimize the design while those other factors collapse, and you've optimized toward irrelevance. Second, desperation drives innovation, but also blinds judgment. The Type 20 program was born from desperate necessity. That desperation generated genuine breakthroughs. It also prevented realistic assessment of whether those breakthroughs could be produced in time to matter. Hope, when it becomes necessary for morale, becomes resistant to evidence. Third, the gap between design and production is where reality lives. Blueprints don't build submarines. Functioning industrial systems build submarines. You can't design your way out of industrial collapse, no matter how brilliant the design. Fourth, and perhaps most important, timing is not a factor you can design around. The Type 21 was a 1946 submarine built in 1944 and 1945 by a nation that wouldn't exist in 1946. All the engineering excellence in the world couldn't overcome that temporal displacement. You can be ahead of your time in design and behind your time in implementation simultaneously. That's not a paradox, it's just reality when context shifts faster than production schedules. The men who worked on Type 21 boats understood something profound. You can do everything right and still lose because the foundations your work depends on are crumbling faster than you can build. That's not a comfortable lesson. It suggests that individual competence and effort can be overwhelmed by systemic failure. But it's true, and the Type 21 proves it definitively. The story ends where it began, with Klaus Hartmann in U-2511 on May 4, 1945. He had the perfect submarine. He had proven it could do everything claimed. He had positioned for an attack that would have succeeded, and none of it mattered because the war was over. He surfaced, surrendered, and watched British sailors examine his boat with professional fascination. They asked technical questions. He answered honestly. There was no point in secrecy anymore. They wanted to know about the speed, the systems, the capabilities. He told them everything. They wrote it down, carefully. Some of what they wrote would appear in British submarine designs 5 years later. Some would influence American boats. Some would show up in Soviet vessels. The knowledge propagated. The implementation that created the knowledge failed, but the knowledge survived and flourished. That's the strange comfort available to people who innovate during collapse. Your work may not save you, but it might outlive you and shape a future you won't see. Whether that's meaningful depends on your perspective. Whether it's true is beyond question. The Type 21 was the submarine that could have changed the war if it had arrived 2 years earlier, or if Germany had possessed the industrial capacity to build it properly in quantity, or if the strategic situation had been different, or if any of a dozen other factors had aligned differently. But they didn't align. History is not a design problem. You can't optimize it. You can only understand what happened and why, and extract whatever wisdom exists in the gap between what was possible and what actually occurred. For submarine designers, that wisdom was substantial and shaped decades of development. For strategic planners, it was a cautionary tale about confusing technical solutions with strategic salvation. For the men involved, it was the experience of being part of something extraordinary that accomplished nothing when it mattered, and everything after it was too late. They lived in the gap between engineering triumph and operational irrelevance, between hope and despair, between what should have worked and what actually happened. That's not a comfortable place to exist, but it's where most genuine innovation occurs. In the messy space between theory and reality, between design and implementation, between what we want to be true and what actually is. The Type 21 exists in that space permanently, neither success nor failure, but somehow both, teaching contradictory lessons that are all simultaneously valid. That's its legacy, complicated and profound and impossible to summarize neatly, which is appropriate. War isn't neat. Innovation during collapse isn't neat. The Type 21 wasn't neat. It was brilliant and broken, visionary and irrelevant, proven and useless, all at the same moment, just like the nation that built it.